Okay, welcome back, folks. My favorite part of this unit, the applications, right? Why does this math matter, right? Logarithmic applications, right? When I talk logarithm applications, it's also talking about the applications of exponents as well, because logarithms and exponents go hand in hand, right? They're related. Okay, let's do finance first. When you deposit money into a financial institution such as a bank, you are in effect lending them money. You are giving them money when you deposit them. In exchange, the bank pays you interest, because guess what the bank does with the money that you deposit in the bank? They don't just let it sit there. Okay, they actually take it and invest it in a whole lot of things to earn interest themselves, and then they agree to pay you back your interest based on the interest they earn. That's how they do it. There are two types of interest: simple interest and compound interest. We will be focusing just on this wonderful thing called compound interest, right? Compound interest is amazing. Okay, here's the formula. A equals P times 1 plus I raised to exponent n. A is the amount at the end of an investment or a loan. P is the principal or the starting amount. I is the interest rate. Okay, always a decimal. I'm going to put that there. When we use the formula, it's always a decimal. N is the number of compounding periods. This is super important. It's the whole reason why we're doing this compound interest. Let me line up. Remember how I said when we're looking at transformations, or we're looking at how we compare a formula to other things that are related, like pancakes, they're best eaten when they're stacked. I'm going to stack these two. We learned exponential functions like this. A value, y value related. P value, A value related. 1 plus I and C, that's the base related. The exponent, n and x related, right? We're just writing our exponential function in a different form to allow us to make finance calculations. This 1 plus I, this is the base of your exponential function. Here, C is the base of your exponential function. Okay, so you know where this comes from. It's just written in a different way. Okay, compounding periods. Before we get into compounding periods, this interest rate is always written in terms of, okay, interest rate is, let's say this, it's related to the compounding period. Okay, and we'll show you why in an example, right? This equation, if you Google it, right, if you look it up, you'll find this equation written in a whole bunch of different ways, right? This is the simplest way you want to use the equation, and understand how to change it into different forms based on what you need to calculate whatever. Okay, and that will help you. So in the diploma, you might just get this simple equation, whereas you might have seen in other forms of this equation written slightly differently. I want you to learn the more generalized form, and then learn how to make it more specific based on what you're doing. Okay, so let's look at compounding periods first. Compounding periods, the number of times per year. So in 1 year, the number of times in 1 year that the bank calculates and adds your interest. So annually, if you compound something annually, you compound it 1 time in 1 year. If you compound something semi-annually, you compound it 2 times in 1 year. If you compound something bi-monthly means every 2 months, right? There are 6 2-month periods in 1 year. So that is 6 bi-monthly periods in 1 year. Quarterly, okay? 4 times. Okay? Monthly, 12 times in 1 year. Bi-weekly, so that's every 2 weeks. There's 52 weeks in a year, so that's 26 times. Weekly, there's 52 weeks in a year, so 52 times per year. Daily, 365 times per year. Okay? Most of these problems, but I mean, this is handy to know, most of these problems will involve those types of compounding periods, right? Most banks will, I don't know, like It's rare to see like a daily compounding or a biweekly or bi-monthly, but just be ready for those problems if we phrase it that way, okay? Let's do some basic examples. Okay, example one. Jungkook invests $7,000 in a 6-year guaranteed investment certificate, compounded quarterly at a rate of 5% per annum. Wow, a lot of stuff here. Determine the value of the investment at the end of the term. Okay, lots going on here. So let's start categorizing all the things that we have and the things that we need. So I have A equals, I'm going to write down my equation, P times 1 plus I to the n. What's my A value? A value is the amount at the end of an investment or a loan. Determine the value of the investment at the end of the term. I don't know that, so question mark. P, what's the principal? The initial amount? Well, that's $7,000. Okay. I, what's the interest rate? Okay, be careful here. The interest rate, 5% per annum. Okay, per annum is just per year. That's just fancy word for year, Latin, right? Per year. So if it's 5%, remember I have to write a decimal all the time, and it's compounded quarterly. That means 4 times per year. Then I take my annual interest rate of 0.05 and I divide it by 4, and I get what? 0.0125, and that's my quarterly interest rate, or my interest rate per quarter. And you have to do this because what is the end value? The number of compounding periods per year. Okay, the number of compounding periods per year, okay, it's quarterly, so n equals 4, right? But it's a 6-year guaranteed investment certificate, so I have to do times 6. This is the total number for the life of this investment, 24 compounding periods. So 24 compounding periods. Okay, I'm going to point this out here. See this 4 here, that's quarterly. See how it's related to the interest rate, 4. Okay, you have to do this when you are using this equation. So let's use the equation here. A, don't know, equals P, which is 7,000 times 1 plus I is 0.0125, the interest rate, the quarterly interest rate, right? Come on. Okay. And then the number of compounding periods, n, is 24. So this is our classic exponential function, 7,000 times 1.0125 raised to exponent 24. My A, investment at the end, investment value, so principal plus interest, so the original amount plus the interest earned, is $9,431.46. Okay, let's ask this question: how much interest was earned? How much interest did Jungkook earn? 9,431.46 minus the original investment, 7,000. So the interest earned is $2,431.46. Next problem. This time, Taehyung invested $2,500 for 4 years compounded semi-annually and received $843.26 in interest. What was the annual rate of interest? Ooh, we're asking about the annual rate of interest. Like we always do, let's write our formula. What do we have? What do we need? My A value. Do I have a final investment? Well, it doesn't say it directly, but final investment is the original investment plus the interest earned. Well, we have those values. A equals the original investment is $2,500 plus the interest earned, $843.26. That is $3,343.26. Okay, our principal, our original starting amount is $2,500. Our interest rate, that's what we're looking for. Okay, our annual rate of interest, let's pay attention to that. We'll come back to that. And the number of compounding periods. Well, semi-annually, that means 2. Semi-annually, that means 2 compounding periods per year, but it's for 4 years, so the total number of compounding periods is 8. let's do our calculation. So I have A, which is $3,343.26 equals P, which is 2,500 times 1 plus I is my interest rate, and N, the number of compounding periods, is 8. So this interest rate we're looking for, right, because I have an 8 here, that's semi-annually compounded, right? So the interest rate is an interest rate per semi-annual period. Okay, so every semi-annual period, so every 6 months, that's the interest rate. So be careful when we end up getting this I value that we know what it is, because we have to turn it into an annual interest rate. Okay, so we'll get to that. Let's clean this up. $3,343.26 equals 2,500 times, let's clean it up. I'm going to divide both sides by 2,500. Okay. Let's raise both to the 1/8 exponent. Why do I do that? So I can get at this I value. I can neutralize or turn that exponent of 8 into 1, right? So let's do that. So I get 1.037 equals, well, that becomes 1 plus I. So 1.037 minus 1 equals I. So 0.037 equals I. Okay, remember, this is a semi-annual interest rate. So I have to take 0.37, 0.037, and I multiply it by 2 to get 0.074. That is my annual interest rate. Let's turn it into a percent, because that's the way we like to look at it, 100%. So my annual interest rate is 7.4%. So 7.4% per annum, which means per year. Okay? Very important. I'm going to put a star here, right? Next page, folks. Okay, you try. I'll pause here, give it a try, and then unpause the video, see how I do it. Okay, I'm back. Jimin invested $7,500 into an account that is compounded quarterly. If Jimin makes $1,200 in interest after 7 years, what was the annual rate of interest? Okay. Okay, do what we did in the previous example. So I'll just step through this. Okay, number of compounding periods. It's 7 years, and it's quarterly, so it's 7 times 4 is 28, and we're looking for the interest rate. So let's fill in our equation here. Okay, remember this I value, that is that interest rate we get at the end, that's going to be a quarterly interest rate, right? We're going to have to be sure to multiply by 4 at the end, but let's finish this, okay? I'm going to raise both sides to exponent of 1 over 28, and that will take that exponent of 28 and turn it into exponent of 1, so I can get at that I. Okay, I need to solve for I, so I get 1.00531 equals 1 plus I, and 0.0053 equals I. Okay, remember, this is a quarterly interest rate. I want an annual interest rate. Okay, so how do I do that? So up here, 0.0053 times 4, that's 0.021. Okay, but I want to write it in terms of a percent. That's our convention. I get 2.1%. This is my annual interest rate, 2.1% per annum. Okay. Next one, Namjoon invests $8,000 in an account which pays compound interest of 6% per annum compounded monthly. How long would it take to the nearest tenth of a year to double in value? Okay, write the equation again. Let's see, what do we have? What do we need? The initial investment is 8,000. If we're doubling it, then my final investment value has to be 16,000. Okay, got that. My interest rate, it says 6% per annum, 0.06. Compounded monthly, right? Remember this formula, it matches the compounding period. The interest rate should match the compounding period. So I'm going to divide this by 12 and I get 0.005 as my monthly interest rate. Okay, so remember that, monthly. Okay, n value. I don't know the number of compounding periods because I don't know the number of years. We're looking for that. How many years, right? How long would it take? So that's what I'm solving for. So 16,000 equals 8,000 times 1 plus 0.005 raised to exponent n. So I'm going to divide 16,000 by 8,000. That's 2 equals 1.005 raised to exponent n. Well, I need logarithms here. So log of 2 equals, I'm just going to save a step here. I'm going to bring that n down, the power rule, n log of 1.005. Okay. Divide both sides by log of 1.005. So log of 2 divided by log of 1.005 equals n. And I get an n value. Let me just write it out with some decimals. 138.9757 equals n. Let's keep those decimals there until we round all the way to the end. It says to the nearest tenth of a year. So let's do this. 138.9757. That's the number of compounding periods. Well, it's compounded monthly, so I'm going to divide by 12. And then that I get 11.6 years. Okay, so this is the years it takes to double Namjoon's investment. Okay, awesome. Next one, J-Hope borrows $7,500 from her parents to buy a new car. His parents, his parents charge interest at the rate of 4% per annum compounded quarterly. When he pays off the loan, he must pay $785 in interest. What was the length of the loan? So you can use this finance formula for loans as well. A equals P times 1 plus I to the n. Principal is 7,500. My A value, I'm going to add the principal amount with the interest amount, and I get $8,285. My interest rate, 4%, 0.04. It says compounded quarterly, so I'm going to divide by 4. So my quarterly interest rate is 0.01. Let's fill it in. 8,285 equals 7,500 times 1 plus 0.01 to the n. This looks like a log application where I need to use log. So I'm going to isolate the n value as much as possible. So that's 1.01 to the n. Okay, I need to take the log of both sides. N log of 1.01. Okay, and then let's further isolate. Divide both sides by log of 1.01. That equals n. So let's calculate that. That's going to be roughly 10.004. Okay. I can't say 10. I have to go up to the next whole number, because if I say 10, that's going to be short of the full term of the loan, right? So I'm going to go up to 11. It's going to be more than the full term of the loan, right? And it's going to guarantee that he pays off the loan. But if I go down to 10, he's going to be short of the time it takes to pay the loan. So that's why it looks a little weird. That's why I have to go up to the next whole number there, okay? 11 is the number of 11 compounding periods, okay? I want the number of years, so I'm going to take 11 divided by 4 because it's compounded quarterly, and that's 2.75 years. Okay, so the loan term is 2.75 years. Okay, you can invest $3,200 into a GIC, which is compounded monthly at an interest rate of 4.5% per annum, remember, per year. How long to the nearest year will it take for Yoongi to make at least $2,000 in interest? Okay, pause it here, give it a try. Okay, what do we have? What do we need? I have my principal amount, 3,200. My final investment is principal plus interest. Okay, my interest rate is 4.5% per annum, but I'm compounding it monthly, so I need to find my monthly interest rate, which is 0.00375. N value, I do not know. That's what I'm going to solve. That's going to lead me to the term of the GIC. So let's set it up. 5,200 equals 3,200 times 1 plus 0.00375 raised to exponent n. Log time, right? Let's isolate isolate n as much as possible. So that's 1.00375 raised to exponent n. Okay, let's take the log of both sides. And log of 1.00375. Okay, and then isolate n. Okay, n equals 129.71135. This is the total number of compounding periods. And remember, we are compounding it monthly, so I need to divide by 12 to go backwards and find the number of years. So that's 10.8 years. Okay, and I'm going to round to the nearest year, which is 11 years. And if I do this investment for, it says to make at least 2,000, I'm guaranteed to make $2,000 in interest at this interest rate if I hold the GIC for at least 11 years.